It is just a delight to be here. Thank you, Cork. Thank you, University of Aarhus. Thank you, Novo Nordisk Foundation. Thank you, everybody, for letting me speak in English. I never take that for granted. My Danish is awful. It would not go well. Speaking of awful, it's awful now. In case you have not been paying attention, we've already failed. We've reached 1.5 degrees. We've reached 1.5 degrees. The goals of the Paris Agreement are largely behind us. No wonder it's not going well at COP. And the Environmental Program of the United Nations recently put out their latest environmental gap report. Emissions went up 2.5% more or less this year. Record global coal use, almost 9 gigatons of coal in 2025. That's 42% of global emissions, just the coal. The chance of avoiding peak warming is 0. 0. Look at that number. The likelihood that we're going to get the 1.5 degrees is 0 because we're at a 1.5 degree world. And when we're going to hit peak warming, what it's going to be is still open-ended, but it's not looking good. This is bad news, right? We've been telling ourselves a narrative for a long time, which has been wrong. And for me, nothing makes me happier than the death of happy talk. Happy talk is the enemy of reason. Happy talk is the enemy of progress. And what the happy talk is it'll all be cheap and easy. We're on an endless glide path to a green nirvana. The market will take care of this. Wrong. And if you could do arithmetic, you knew this a long time ago. The arithmetic of net zero is actually pretty compelling. The only way to get to stabilize the climate is 0 emissions everywhere in all sectors forever. That's the work. It's not switching stuff. You have to get to 0 everywhere forever. And if you emit anywhere in any sector, you have to unemit the same amount. That's the removal piece. Today, we do not know how to solve 20% of the emissions, which means we're looking at 10 billion tons a year of unremoval, of unemitting. 10 billion tons. For scale, human beings everywhere in the world together weigh about half a billion tons. So 20 times the mass of humanity. It's a big number. Another number to give you sense of scale here, Royal Dutch Shell, every year they move 300 million tons of stuff. So to remove 10 billion tons of stuff, we need 30 companies the size of Shell. That's the work, right? And we can't just turn it into stuff. I like that, but we got to mostly put it underground because that's where it came from. Thankfully, our enterprise has matured a lot. Bill Gates famously said, we overestimate what we can do in 1 year, we underestimate what we can do in 10. So I'm here to give you some perspective. I'm a pretty old, grizzled warrior in this space. I've been in the carbon removal and carbon management business for almost 25 years now. And a lot has happened that is cause to celebrate and why this room exists and the people in this room. So let's start about the basics. What is carbon management? It includes carbon capture and storage from a point source. You concentrate it at a facility, you put it underground. That is an emissions reduction job. The only reason you do this is to reduce emissions. That's it. That's what it's for. You can also remove CO2 from the air and oceans. It draws CO2 out of the air using nature-based, using engineered, or using some kind of a hybrid system. I would call BECCS a hybrid system. That's emissions removal, not reduction. We need that every bit as much as we need the reduction. And you can turn carbon dioxide into stuff, CO2 utilization, cement, fuels, polymers, whatever you want to do. Depending on where that's coming from, it could be reductions, it could be removals. All of these have different places in the markets. That's the good news. All of these have different prices. That means you got to be thinking carefully about what it means. The science behind what I said is not contested. You might have heard of the United Nations Framework Convention on Climate Change. You might have heard about the IPCC. All scenarios require a lot of carbon management. All of them. There is no scenario without carbon management. 0. Something on the order of 4 to 7 billion tons of carbon capture and storage. Something on the order of 10 billion tons of CO2 removal. And I was very pleased to hear Johann Rockström say this recently, another grizzled old carbon warrior. He said, removing CO2 from the atmosphere is vital to avoid the catastrophic tipping points. It's not some greenwashing thing. It's the job. We got to do this. We got to do it big. So perhaps returning CO2 to the geosphere is part of the job. So what's happened? Let's talk about carbon management from the past 100 years. I'm not 100 years old yet, but I have a long view of these things. And in fact, we've been doing carbon management for a long time. I split this into before and after Schleipner. Before Schleipner, we started capturing CO2 in the 30s, actually. The first commercial design was from this gentleman here, Mr. Bottoms, at the Girdler Corporation, who came up with the amine capturing solution. I haven't been able to find yet the first operation of this, but I believe it was in Norsk Hydro in 1938 who began to make urea with this. The first CO2 storage was in 1972. You remember Royal Dutch Shell? I mentioned them earlier. They drilled into a naturally occurring CO2 dome. They thought they were going to get natural gas and they got CO2. And they're like, oh, what can we do with this? They're like, oh, well, we can inject it underground and get more oil out of the ground, which is what they did. The first 2,000, 3,000 miles of CO2 pipelines in the United States were built for that purpose. This also came with the first CO2 pipeline regulations. The Department of Transportation has been regulating CO2 pipelines for 53 years. It was first proposed as a climate solution in 1977. Cesar Marchetti basically figured out that you could do this, which is great. But Schleipner was the first thing, really. This was the first time we did it for climate. The reason why? Carbon tax. There was basically in Norway at the time what was a $50 a ton carbon tax from industry. It only cost them $12 to put it underground. Voila, they figured it out. And they pulled CO2 out of the ground with the natural gas and then put the CO2 back in. The most important thing is it showed that you could do it and see it. You could demonstrate the CO2 stayed underground. They've been monitoring it for 27 years. They still know that it stays underground, and they've done mass balances and showed that. So when people say, oh, it's an unproven, untested technology, pull out that picture, say, Schleipner, you're wrong. We know that this works, and it works fine. The first power project was in Canada in Boundary Dam. They got serious about this. These are big pieces of equipment. These are expensive pieces of equipment. But they captured 1 million tons a year out of the gate. A little company that was a liquid solvent company jettisoned forward because they were acquired by Shell. And you were able to get a lot done. The first steel project is old. People are like, maybe we can make fossil-free steel. We've been making emissions-free steels in Abu Dhabi for a very long time, actually. And they've been at the Al Rayada plant. I was fortunate to be at the ribbon cutting for that many years ago. Now they're capturing CO2 from cement at the Brevik plant. I'm sure you're all familiar with that facility, right? People keep saying, oh, well, that's not what I'm talking about. Like, I mean something else when I say carbon capture. We've done it now in all sectors. We've done it now in many different kinds of industries. And now we're shipping it around, which is useful for Denmark, which is useful for Germany, which is useful for other Nordic countries, which is useful for Japan, which can't store CO2. In fact, that's a Japanese ship that's moving CO2 around. So in fact, the world has changed a lot in this regard. So much so that people have lost track of the fact that we now have 77 projects in operation worldwide. Not 3, 77. And they capture 64 million tons of CO2 a year, and there's another 47 million tons under construction. Not like some phantom, like maybe like they're being built, they're going to operate. That is a 17% increase in projects year on year. Not a lot of sectors grow 17% year on year. That's pretty impressive. The world's biggest one of these things is, perhaps counterintuitively, in Saudi Arabia. The Jubail hub, in a year and a half, is going to open up. They're going to capture 9 million tons of CO2 a year. That's a lot. That's a big number. But not as big as what they're going to do in 2035, which is 44 million tons. This one facility will equal all the CO2 captured and stored in the world. One facility, 44 million tons. That's like taking 10 million cars off the road. It's a big number. And that's great. So that has matured a lot. How about the technology and the business model? I was saying earlier, like, This is a CO2 forum. Maybe we should talk about some of the CO2 technologies that have come to market and how people are making them. Let's start by the fact that the costs have come down and the performance has gone up for all of it. The costs have come down, the performance has gone up. This is one of the few things human beings are really good at. We're really good at reducing cost and improving performance, right? And this is no exception. For solvents, there's now a bunch of companies that will give you a delivery with a performance guarantee and a wrapper. That means it can be insured and priced like a commodity in the market. That's a big deal. And these are not like little companies. They're like Schlumberger and Linde, Shell, Aker. These are companies, Fluor, like they actually really exist and do things. And there's a whole bunch of stuff coming right behind them. There's a next generation of stuff that is half the cost, that makes no wastes, really good stuff. And we're now doing it in cement. I also have got to say, like, we're going to be doing this on natural gas power very soon. The last holdout, everybody's like, well, you haven't captured CO2 in a natural gas plant. Can't say that in 2 years. In 2028, Teesside will turn on and then we'll have captured CO2 from a natural gas plant as well. But solvents are not the only technology out there. We've moved very far on sorbents. The leader here is Svante. Svante now has a factory that can make 10 million tons of capture capacity a year. And they're doing it for things like natural gas and cement and ships and other kinds of things. Things like metal organic frameworks, which were considered sort of toys 20 years ago, sort of like, oh, that's kind of interesting, I don't know. Like now BASF and 3M make them at the 1,000-ton-a-year scale. It used to be gram aliquots, now it's 1,000 tons a year. That's good. Oxy-firing, coming along. Slower than I would like, but still big players out there. Clean Energy Systems, Net Power, Arbor. We're going to see the first one of these things really commissioned before 2030. If that stuff works, it could be very cheap, could be very useful. These things have already shown a 50% cost reduction over the past 15 years. We're still leaving 85% of the exergy on the table. There's another 50% that's pretty easy, actually. Let's talk a bit about CO2 removal. I'm old enough to remember when if you said CO2 removal, people would say, go. They'd be, boo, how dare you? We're in polite society, we don't say such things. If you were an engineer, people would say, boo, this is the worst way to do it. It's so expensive to pull CO2 out of the air. Well, we failed, we have to do this. And, in point of fact, we're now building, about to commission a 0.5 megaton plant in Texas. If you've never been to No Trees, Texas, it is correctly named. There are no trees. But they have now a 500,000 ton facility that will be commissioned very soon. If you like bioenergy with CCS instead, you don't have to go far. This facility will be up and running in a couple of years. In Stockholm Exergy, 800,000 tons. It'll be the biggest CO2 removal facility in the world. And about 1 million tons, which is getting to the right level. The Swedish government gave him $1.8 billion to do this. That's a good thing to do. CO2 removal, we've got the DAC example of 1.5, that's solvent-based. BECCS is also solvent-based at Stockholm Exergy, but the sorbent-based technologies are the darlings that you're all familiar with. Climeworks, Carbon Capture Inc., Octavia, all of these other kinds of companies, and they all have different structured sorbents. They all have different designs. It's actually quite a lot of innovation going on in this space. It's a completely novel operating system in Heirloom. Their slogan is dumb sorbents, smart robots. They're basically using rocks as the solvent, as the sorbent. That's pretty dumb. But it works. And there's lots coming up behind them. Companies like Atvos, which are using a resin. There's the humidity swing adsorption technologies. There's all these other things out there. The membrane-based technologies, I would go with the direct ocean capture ones. Things like Ebb or Captura that are really using these kinds of tools to separate CO2 from the ocean, solving ocean alkalinity and ocean acidification at the same time. For new technology, look at a company like Arca. They turn waste rock into CO2 removal. That's a good business model. I'll talk more about them in a minute. Biochar was too many companies to count. I personally like the SkyClean guys and Nick Stiesdahl. I think he's got a really great technology, but they're one of many. And enhanced rock weathering is starting to come in. Companies like Ondu and Mati and others. So Arca, I just wanted to point out, like, these guys just take waste rock that's lying around, they stir it. That's a pretty simple technology. That's the Russian tractor of carbon removal. It does the job. One site, they have 7 billion tons of rock waste. So they can get a good volume in this one place. CO2 recycling is coming into its own as well. You're all familiar with companies like Carbon Cure and Carbon Upcycling. They also do mineralization, but they turn CO2 into concrete. Concrete lasts a long time. Also making aggregate, companies like Neustark. They're using waste cement and taking advantage of that to make CO2 removal stuff. There's hard stuff like fly ash and steel slag. People thought that was easy. It's not easy. Turns out it's hard. It's problematic, but people are working it. We'll get there. Making fuels and chemicals, you're fighting the second law of thermodynamics. That's super hard. Our prior speakers talked about that. Like that's a real thing, but it turns out we'll probably need that too. We'll need e-jet. Companies like HIF are doing that in the market today. We'll need e-methanol. There's a handful of companies out there doing that. The challenges are mostly around cost. That's about getting clean electricity as much as anything else. And you also need to have a supply of CO2, which is harder than it sounds. But in fact, we took a look at this seriously when I was at Columbia University. I want you to focus on that goldenrod, that orange line there. That's market parity. So if you really want to get something in the market, it's got to be actually a little below that price because people can keep using the same stuff. So it needs to be significantly cheaper. And if you look at all the things you can make, there's only a couple of things that are there right now. Precast concrete, concretes, carbon monoxide is in that category. Ethanol, that's kind of it. But the other stuff, it's only 2 to 4 times more expensive. 2 to 4 times more expensive, we can do. That's just science and engineering. You can make that happen and you can turn it into a company, and that's within the policy support window. That is doable. So, how do I think about this? I'm very optimistic about things like low temperature electrolysis. I think that's going places. We're going to have cleaner grids. We're going to be able to use the electricity. We're going to make carbon monoxide, for example. I'm pretty optimistic about things like solid oxide electrochemical cells. I think we're going to get there to make syngas. Syngas is very useful stuff. If you can make syngas, you can kind of make anything. That's good. I'm more cautious about like the reverse water gas shift syngas production, reverse water gas shift methanol. That's just harder. The costs are fairly mature, so it's hard to really bring those costs down. You need to jump the curve somehow in order to do that. So that's a new technology venture. I'm very cautious about things like solid oxide electrochemical cells for carbon monoxide per se. That's different from the electrolytic cells. And things like direct methanol production from electrolysis. We're going to get there someday, but that's just research right now. You got to move 8 electron pairs. That's hard. But we can make concrete. That's easy. We can make aggregate. That's easy. The world uses 30 billion tons of concrete a year. We can probably get a gigaton into that. We should. And in fact, the Carbon Cure facility has already got 400 sites operating. They've put 500,000 tons of CO2 in. Neustark, already moving fast. Small, but moving. HIF has actually started construction here in the Atacama Desert. The HIF team is making stuff. At 12 up in Washington, they're making jet fuel out of CO2 and green hydrogen at a decent scale. And at a decent price. Yes, it is more expensive than jet, but it's not crazy. You know how we know it's not crazy? They got $650 million to build it. The business model innovation is every bit as important as the technical innovation. The business model innovation is every bit as important. Every bit. One example, environmental attribute certificates. Those didn't exist 3 years ago. They exist now. That is a way to decouple the carbon attribute from the physical product. So if you're Microsoft and you want to buy green concrete, you don't have to ship the concrete from Brevik all the way to Sao Paulo Alto. They can just buy the environmental attribute. And they will pay the green premium. So Brevik can sell at a market equivalent and Microsoft can take the green premium. The same thing for synthetic fuels. The same thing for green steel. This is a way to get stuff into the market. It's a big innovation, actually. And the carbon accounting on that's actually very clean and very straightforward. Another big market business model improvement is advanced market commitments. Somebody said, we won't actually pay you money, but we're going to put a fictional big bag of cash on the table. And if you can deliver 100,000 tons of abatement, we will give you that big bag of cash. That advanced market commitment is enough to get debt from a bank. That's enough to build a facility. So the conversation has not been about, well, how do I improve the efficiency of this, that, or the other? Now the conversation is, can I get JP Morgan Chase to buy 200,000 tons of my stuff? And if the answer is yes, you can build your facility. We are increasingly doing blended capital, philanthropic blending with private funding, private with corporate, with public. This is hard. So people are like, well, I can't pay for all of it, but maybe I can pay for some of it. I'll give you a grant, I'll give you a loan, I'll give you something. And that's the way that we can get things going. Sometimes that comes at the early stage, sometimes it comes at the late stage, but either way, people have realized that we need that to work. This is not IT, where you have sort of an endless open white space. Like, no, you're like competing with incumbents in a real market, so the money is important. We have to figure that out. And governments are starting to buy this stuff, which is useful. Governments buy 50% of the concrete in the world. They buy 20% of the steel in the world. They buy 5% of the fuels. And they're starting now to buy CO2 removal. The UK government, the Canadian government, others. So what's happening in the market, I'm going to be super brief here because my colleague David, raise your hand, David, is going to be on stage talking about that in just a minute. But against the story that you might hear in the news, companies have not backed down from their corporate commitments at all. Quite the opposite, they have doubled down. Green hushing is common. They have not talked about it as much, but they're spending more money in more ways. Their purchasing and investments remain significant. I would much rather have a company that talks less and does more. That's kind of the world that we're in right now. Unfortunately, the voluntary carbon market is mostly bad. Still mostly bad. Only 4% of what's in that market is actually valid durable removals, which means the other 96% isn't. This is a challenge for policymakers, for companies. How do you figure that stuff out? How do you get the good stuff in the market? How do you avoid the bad stuff? And in fact, what we're seeing is the voluntary carbon market is actually two markets now. It's split. It is bifurcated. There is what we would call a high-risk market. That's all those colors up to A. And then there's the high-quality market. The high-quality market is the stuff that's AA or AAA. It's a small volume, but it is happening. And that split in the market is a rush to quality, and people now accept that high-quality CO2 removal is the floor, that buying junk is not the same thing as doing CO2 removal. You're paying for an environmental service, so you better get that service. And if you're a corporate procurement officer, you want to buy stuff that delivers. And so this is beginning to change. And in fact, we're seeing not just high volumes of forward offtakes in general, but we're starting to see an increase in the high durability purchases. Significantly more of these. I want to remind everybody, though, that deployment is not about cost. It's about finance. Said differently, if we cut the cost by 50%, we'd still sell zero of it. We got to get paid. An investor has to make a return. It's about finance, not cost. So I put this helpful slide up here showing about the subsidies that the United States government has paid in the past for different kinds of things. This mostly came out of the Obama era. This was the American Advanced Recovery Act. I can't remember the name of the bill. But anyways, we paid hundreds or thousands of dollars to subsidize various kinds of things. My favorite is cash for clunkers. Cash for clunkers was like $400 a ton of abatement. They did cash for clunkers because they wanted to keep people buying cars. Like that part of it was getting Detroit going. Like policymakers have their own way of thinking about the world. Climate's not necessarily the thing that gets them up in the morning. But we paid lots of money for this. Carbon capture is in that window. That is cheaper than almost everything we've subsidized. By a lot. People say, oh, direct air capture is too expensive. We can never do it. Direct air capture is cheaper than what we did for batteries and electric vehicles. In California, the subsidy for electric vehicles is $7,000 a ton. Direct air capture is quite a lot cheaper than that. So we need business model innovation. We need technology innovation. We also need policies that are durable. This is a team sport. Everybody has a job. And the good news is that we are moving out of a voluntary market into a compliance market. It's helpful to think about what we're doing here as an environmental service, like trash collection. It's not necessarily glamorous, but every government in the world mandates trash collection. You got to do it, right? And in a compliance market, everybody pays, which means you can get paid too. And we're starting to see these happening. The CORSIA is the first out of the gate. This is the International Civil Aviation Organization, ICAO. And basically that becomes mandatory, next year. And we are nowhere close to the volumes that we need to hit that market. We're starting to also see alignment between EU directives, but also new policies in places like Japan or Brazil that are quite forward-leaning and forward-looking. These are laying the foundations of compliance markets. And that's a good thing because we need to get paid to do this stuff. Engineers don't work for hugs. So this is the first compliance market, and you can see the trajectory here of where the prices got to go. Focus on that little thin red line down there at the bottom. That's the amount of credits that are around. We're hilariously outgunned on this. There's nowhere near enough quality supply to even serve the lowest level of mandates. There's nowhere enough credits. In fact, that meant that the market for these credits heated up so much they had to freeze trading because everybody is like, oh my God, there's not enough supply. We should be buying and selling right now. What is important is that the ICAO actually accepts now CCS and CDR in their pathways. Not all of them, but some of them. So if you don't know anything else, you can get paid this way. Globally, engineered carbon removal credits are accepted in no emissions trading scheme. Again, 0% of the world will allow you to do this. That's going to change really fast. It's going to change in Europe, which has just said that they're going to have carbon credits by 2040, 6% or something like that of the total. They've already said, yes, we're going to do this. Japan has also said they're going to do this. I'll come back to Japan soon. It is likely that the demand for the engineered CDR will start at the voluntary carbon market, but will move to a compliance market within this decade. What's happening around the world? In the United States, it's not good. We're stepping backwards. It has canceled almost all of the tax credits in the One Big Beautiful Bill Act. But in point of fact, they did not cancel the DAC hubs yet. They did not cancel 45Q, which is the way to get paid. The United States is surrendering its global leadership on this topic. This makes me extremely sad. If you're a country like Denmark, you should take heart in this. There's an opportunity waiting for you in this. At the last minute, California vetoed a really good-looking law. I was very sad to see this happening. We are surrendering the opportunity to lead in my home state. I wish it were otherwise, but so it goes. EU, kind of different. They've set very ambitious targets for 2030, for 2040, and for 2050. And in point of fact, that will require huge amounts of carbon management. By 2040, you're looking at 280 million tons of carbon capture. About a quarter of that is removal. By 2050, they're anticipating 55% of that will be removal. It's the only way the math works. Like I said, the math of net zero is clarifying. You have to remove as well. So we see a mixture of progress and paralysis in the EU, which is okay. That's kind of your brand. That's okay. But a lot of very useful stuff. The carbon border adjustment is actually pushing this stuff around the world. That's very important, actually. It's part of the reason why Japan is investing in Denmark. Not the only reason, but it's part of the reason why. There are uncertainties around what are the criteria that will qualify. How will we know it's good? Has the science been delivered? These are good questions. The EU is being judicious in this regard. They're not rushing to a standard. They're saying we're going to take our time, we're going to do the science, we're going to understand it. But even modest integration of carbon capture and CO2 removal into the ETS will be huge for the markets. The tons are very, very large, and the money is quite good. Japan, though, is now the global leader in my book. They have committed $1 trillion to abating in their economy. Not 1 trillion yen, $1 trillion. The amount of total carbon credits that have been sold so far, 10 billion. So this is 100 times more than that. It's a lot, and it'll go in every sector of their economy. They will do a lot of nuclear. They will do a lot of hydrogen and ammonia. They will do a lot of green fuels. They will do a lot of carbon capture, and they will do a lot of CO2 removal. What exactly this means, not quite sure yet. The Ministry of Energy, Economy, Trade, and Industry is still sorting that out, but they'll probably issue these rules in March, or the draft or these rules. In a year and a half, it'll be done. This time, 2 years from now, we'll know what constitutes an acceptable credit in the Japanese market. Korea is about 2 years behind. They have a new president who's very ambitious about this. Singapore is intellectually ahead of these guys, but they're going to be more cautious. It'll be 5 years before they start spending real money. In the MENA region, the Gulf region is surprisingly a leader in this space. Guess what? They have money, they have ambition. That's a good mix. The UAE has said they're going to build a billion-ton project. The Altera Fund is $100 billion for clean energy in the developing world. That's also real money. Saudi Arabia is building direct air capture projects. They're leading the CDR effort in mission innovation. They're building the world's largest CCS hub. There's going to be CO2 removal in there somewhere. And we're seeing global progress in the global south, kind of on all fronts. Octavia Carbon keeps winning. I just love these guys. It's actually a really indigenous technology. One of the things that I love about these guys so much, they innovate really fast. Really fast. As in they got a factor of 10x improvement in 6 months fast. Watch them. They're moving at an incredible pace and doing incredible things. Same thing with biochar. India is probably the place to look for this stuff. But they're not alone. We're seeing it all over the place, including here in Denmark. Mobile technology units that can grab agricultural wastes and help farmers. Enhanced rock weathering is coming on fast too, again in India. Mati won the Musk Prize recently. It's sort of useful stuff. So just to close, what's left? What are the worries? What are things to be bothered by? Well, there's 3 big choke points in this. Top of the list, not enough people. We need 30 companies the size of Royal Dutch Shell. We are hilariously understaffed for this job. So we need to focus on the trades, on the permitting, on the regulation. Every aspect of this needs human capital in it. The infrastructure is another piece. The United States has 8,000 kilometers of CO2 pipeline. Europe has 100. Not going to do the job. The rest of the world, 0. We're going to need the infrastructure. That also means we're going to need things like transmission and distribution, better power systems, like all this other stuff for CO2 utilization. We don't have the infrastructure for that either. So we got to build this stuff for real. We also need to pay attention to human beings. Mr. Gates got a lot of pushback from his memo recently, but he said something important, which is if you want people to do things, you should help people. It's not a crazy idea, actually. And these things all live in communities. If your community says no, it's over. You have to figure out how to get communities to say yes. And that's not by preaching them on the science. That's by trying to understand them. And one mouth, 2 ears, good way to enter a community. We also have to improve permitting. I heard something terrifying last time I was here in Denmark. I was told that in order to get an offshore wind permit, it takes 7 years. There is no country in the world that loves offshore wind more than Denmark. How can it take 7 years to get an offshore wind permit? But it does. If Europe's doing this, ain't gonna win. But there's a lot to do. So what should we start with? Let's talk smarter about this. Everyone has all of humans' knowledge at their fingertips now. Learn something. Learn something outside of your discipline. That's a good way to start. If you're a scientist, learn something about finance. If you're a policymaker, learn something about engineering. Take some time, learn, then engage communities proactively. Talk about this at dinner parties. You won't be loved, but people will start realizing that it's a good thing to, that they will go, oh, I didn't know anything about this. Now I just know this is an irritating person, but at least they'll have learned something. Seek political compromise. This is so important. This is so important. Every time I've gone to Washington to talk to policymakers, they know the science already. They already know it. They are solving a different problem. They're like, how do I get this through a committee? So you have to figure out how to help them get to yes. That's good work. In our business, we do not have good standards. We need to do a better job of that. We need standards for fuels, for CO2 removal, for biochar. Like, we need the standards. That's important work. Do it. That's collaborative work as well. It's not just scientists huddled in a corner. Like, we actually end up having to talk to policymakers and investors to get that right. And lean in. If only we could make human capitals, if only there were universities that focused on this, perhaps there would be a way to get more people in the business. And we got to reimagine risk. If this is all getting done by single project finance, we're totally going to fail. This is not going to be fast enough. We have to reimagine the way that we accept risk in financial arenas, or else we're not going to put enough money into it. Jeffrey said earlier, like, where you need to do things on the order of like $250 billion to get this stuff to yes. That's not going to happen if every time somebody's like, am I really going to get a 15% rate of return? We have to reimagine the risk. But if you have the right ambition and you match that with humility and you match that with money, that makes progress. That's the recipe. Ambition plus humility plus money equals progress. That's how you get the job done. And now is the time to invest. Because 10 years ago, this wasn't a thing, but it's a thing now. Couple of parting thoughts. Be fierce and be numerate. If you have numbers behind you, you're going to beat every time. Use good numbers. Be fierce about it. Be open-minded. You have to work outside your discipline. It's going to be the way that we make progress. You have to understand that there are people who will disagree with you. That's okay. If you can still get them to yes, that's a win. And then be humble. Complex problems have complex solutions. You can't possibly know it all. You can't possibly do it all. And there's many forces that are beyond your control. In politics, in economics, in social science, you can't control any of those things. But if you match that humility with ambition and with resources, you'll have progress. Thank you very much.